Hi everyone, I'm Zhijie Wang, a PhD student at the University of Alberta and Alberta Machine Intelligence Institute. Today I'm presenting our work PromptCharm, text-to-image generation through multimodal prompting and refinement. This work was done in collaboration with researchers from the University of Alberta, the University of Tokyo, and Purdue University. The state-of-the-art text-to-image generation model can create really beautiful and amazing pictures. Here is an example of an image created with a stable diffusion model. The key to a good creation is prompting. However, writing prompts like this, which is complex and includes a lot of magic keywords, is not that easy. Therefore, prompting usually becomes a trial and error process for novice users. One way to assist novice users in prompting is by using an interactive prompting system. Some of the research efforts have been dedicated to interactive prompt engineering. To understand the user needs for interactive prompting, we conducted a literature review of previous work that has done user studies about prompt engineering or generative design, as well as those design guidelines for human-AI interaction. In summary, we found that, first, the system needs to automatically comment and revise text prompts. Second, the system needs to balance automation and the user's control. Third, the system needs to support users in exploring different prompting options. Fourth, the system needs to have version control to help users keep track through iteration. And finally, the users wish to have model explanation for those AI-generated contents. Based on these user needs, we designed PromptCharm. PromptCharm integrates a reinforcement learning model to help users automatically refine text prompts. PromptCharm further supports multi-modal prompting to help users improve their creation. When users click on a specific keyword, a set of different options pop up. The users can delete, replace, or adjust the model's attention to a specific keyword. They can also explore this keyword in a large database. When clicking on Explore, the system will retrieve images including such keyword from a large database. This database is called Diffusion DB, which includes millions of prompt image pairs. When the users click on Attention, they can adjust the model's attention to one or multiple keywords by using this slider. To achieve this, PromptCharm designs an algorithm to control the model's cross-attention layers. These cross-attention layers usually have significant effects on the model's interpretation of text prompts. Controlling the model's attention can resolve concept misalignments between the user and the model. For example, here the model originally generated two wolves in the image. By decreasing the attention to this keyword wolf, the model now quickly renders only one wolf in the image. When the users click on Replace, PromptCharm will retrieve the most similar and dissimilar keywords for users' replacement. These keywords are again extracted from the large database Diffusion DB. We first mine the most frequent keywords, and then we use the cosine distance in the embedding space to determine the similar and dissimilar keywords for users. Even with all this support, the creation itself is still an iterative process. PromptCharm, therefore, provides a rich feedback loop to help users iteratively improve their creations. To help users understand why the model generates a specific content, PromptCharm renders model explanation on both text prompts and images. These explanations are generated from the cross-attention scores on tokens, and then projected to the pixel of the generated images. PromptCharm further supports direct manipulation by enabling users to edit the generated image directly. Finally, a version control opponent is enabled to help users keep tracking their creations over the iterations. Overall, PromptCharm is designed and implemented to be a mixed initiative system for prompt engineering. We conducted two user studies to evaluate the usefulness and usability of PromptCharm. The first user study includes closed-ended tasks. We created two variants of PromptCharm as a baseline systems, one with a plain text editor only, and one includes the prompt refinement model. The study was designed as a within-subject study with 3 different sessions. We invited 12 participants from different backgrounds. Most of them have 1 or less than 1 year of experience with generative AI. During each study session, each of the 12 participants were asked to replicate one given image using one of the 3 tools. We found that PromptCharm users achieved significantly better performance according to both objective and subjective metrics compared with 2 baseline users. On the left-hand side, we use the structure similarity index to directly compare the user-generated images with the targets. On the right-hand side, we ask the participants to self-rate their creation similarity compared to the targets. In the post-task survey, participants also rated their assessment of PromptCharm's features. Image style exploration and model attention adjustment are the most liked features. One participant said, "Exploring different styles in PromptCharm can help me understand them in the suggested prompts." Another participant commented, "PromptCharm can precisely catch the parts that I want to improve through attention adjustment." In the second user study, we reused the same baselines while enabling an open-ended task. We invited another group of 12 participants. Most of them are again with 1 or less than 1 year of experience with generative AI. During each session, each participant was asked to create an image given a specific scene. For example, a dog is playing with a cat. We found that PromptCharm users again achieved the best performance among 3 groups. They felt their creations were more aesthetically pleasing and matched their expectations more precisely. While the same features might have been used in closed and open-ended tasks, we found they were used in different ways. For example, when performing closed-ended tasks, users use image style exploration to help them understand a specific image style, so they can understand the target image styles that they need to replicate. However, when performing open-ended tasks, users prefer to simply use this feature to try out different combinations. As a result, one participant commented that, "PromptCharm gives me a lot of different image style suggestions, so I can generate my image more freely." By contrast, one baseline user said, "It was easy to me to describe an image scene, but it was hard for me to provide keywords about image styles." Our user studies also brought us a few design implications. First, we found the importance of model explanations in assisting prompt engineering. During our user study, one participant found that the model repeatedly created 2 penguins instead of 1 given this prompt, a cartoon image of 1 penguin playing in the snow. They resolved this only after replacing the keyword playing with rolling. Then they realized that the model might have been over-attending to the keyword playing. However, without model explanation or attention visualization, locating such a problem is not easy. Second, enriching the user feedback loop in prompt engineering is a must. The model should be able to provide feedback about the generated content, while the users should be able to direct the model about the generation process. This also aligns with one of the design principles for mixed initiative systems, providing mechanisms for efficient agent-user collaboration to refine results. Third, the system needs to help address users' conceptual gaps. We found the problem of selecting image style keywords is very similar to the selection barriers in end-user programming, where the users know what they want the computer to do, but they do not know what to use. PromptCharm helps users in selecting keywords by providing example images retrieved from a large database. One participant said about the image style exploration. "Initially, I have no ideas about these keywords. However, I found PromptCharm addressed my need by supporting me explore the generated prompts keywords with example pictures." And finally, we found that experienced users might use the system in ways different from the novice users. This is similar to the exploration and exploitation modes in the user's programming with AI. We suggested that the future interactive prompt engineering system should support both 2 modes. This is all about my today's presentation, and here's a preprint version of our paper as well as video demos in our open source code. Please feel free to reach out if you have any questions. Thank you.